What's going on, guys? Let's look at this problem right here. This question is asking a convex planar lens of index 3 by 2 has a thickness of 1.2 centimeter and a radius of curvature of 2.5 centimeter. Determine the system matrix when light is incident on the curved surface. Here they are asking for the system matrix, and to find the system matrix we use this general equation, that is A is equal to 1 minus d2 dl over nl, and in the first row second column we have negative d1 d2 plus d1 d2 dl over nl, and in this second row first column we have dl over nl, and in the second row second column we have 1 minus d1 dl over nl, Okay, now let's see what are these terms representing. The d1 is basically the first side of the lens, like the power in the first side of the lens, that is d1, and actually this is minus d1 minus, and for power in the first side of the lens, and d2 is power in the second side of the lens, and dl is thickness of the lens, and nl is index of refraction of the lens. Now let's see what are the given information here. Here you can see index of refraction is given, that is 3 by 2. So we have the nl, that is 3 by 2, that is equal to 1.5, and also they have given the thickness, that is 1.2. So we know the dl, that is 1.2 centimeter, and we have to find out the power in the first side and power in the second side. And also they have mentioned this is a convex planar lens, and convex planar lens look like this, right? So the first side we have a radius of curvature, that is given by 2.5 centimeter. R1 is equal to 2.5 centimeter. And if you look at the second side, this is a flat surface, right? So for a flat surface, R is infinity, so R2 is infinity. Now we have R1 and R2. Now we can find the power in the first side and power in the second side. To find the power, we use this equation, that is D1 is equal to n minus 1 over R1, and for the second surface we use negative n minus 1 over R2. And here we know the n, that is index of refraction of lens. Let's put nl, index of refraction of lens, that is 1.5 minus 1 over the R1, that is 2.5, and for the second one we put negative 1.5 minus 1 over infinity, and this one is going to become 0.5 over 2.5, that is equal to 1 over 5, 2 over 10, that's going to be 0.2, and this is going to be 0 because we are dividing this by infinity, so this value is 0. Now we have the d1 d2 values. Now we can find the system matrix. Now to find the system matrix we are going to plug all the values. So A is equal to, first one, 1 minus d2 by these values, and we know that d2 is 0, and if you multiply anything by 0 that's going to be 0, so 1 minus 0 because the whole thing is going to be 0. And here we have minus d1, d1 is 0.2, minus d2 0, and then again we have a d2 right here, so that's going to make this one everything 0, so this is going to be 0. And here we have dl, that is thickness, that is 1.2 divided by the index of refraction, that's 1.5, and in the other side we have 1 minus d1 is 0.2 times the thickness, that is 1.2, divided by the index of refraction of the lens, that is 1.5. Now let's simplify this one. This is going to be 1, and here we are going to have negative 0.2, and in the bottom we have 0.8, and here we are going to have 0.84, and this is going to be our system matrix for this question. I hope this helps. Thanks for watching.